Start recording. So, hi everyone. Thanks for joining. Thanks for putting aside a bit of time in the middle of your day to come and discuss this. I'm Finley. I'm an aerospace engineer. I'm part of Safe Landing. Safe Landing is for aviation workers anywhere in the sector, whether you're a pilot, cabin crew, air traffic controller, engineer, pilot. You're welcome to get involved in this group. It's a global group for anyone anywhere in the world that wants to help reduce the climate impact of aviation. I'm just covering a couple of principles of our group when we founded. So we believe that our industry should be honest about the total environmental impact of flying, be realistic about the limits of technology to solve this problem. This is very appropriate to negative emissions technology that we're going to discuss today. We also want to be transparent about future regulations and policies that are required to reduce emissions and not lobby against those things, and have a plan that accounts for all of that and supports aviation workers during the transition that will inevitably need to take place. So our positions based on those principles are that flying does have a high environmental impact. We need to be clear about that. It's also highly inequitable. This means it's unfair. It's unfairly distributed. There's only a small minority of people in the world that can really access air travel and produce the majority of emissions. Technology will not be available at scale in the time required. We have sort of 10 to 15 years at most, and just technology cannot scale in time, so we need to do something else. So future regulations are vital, and this includes limiting air traffic capacity, which is a difficult conversation for aviation workers, but it's one that we want to have because we think it's fundamental to this. So acknowledging this and planning for this is in all of our best interests, including the aviation sector and including aviation workers. And that's what we want to do today. So we're going to talk about negative emissions technology. We've got a draft position on this, and we've got a few different positions. We've been drafting sustainable aviation fuel, carbon offsetting, that sort of thing. I'm really keen for people's input on this. So this is a bit of a presentation of where we're at with our thinking, and we're really keen for the input of our community. On the agenda, I'm going to cover firstly what are negative emissions technologies, and then our various positions on them. This includes the fact that they seem to be unreliable, unproven, inefficient, expensive, unfair. And there's also a really important question over if we do scale them, who is paying for it and who is benefiting from them. And then I'll just give a quick summary at the end. But yes, negative emissions are often kind of depicted as a bit of a vacuum cleaner that are magically going to suck up all of the carbon from the atmosphere and return it back underground. So what are negative emissions technologies? So this basically refers to industrial processes, so distinct from a natural process like reforesting, rewilding, where trees grow or plants grow in a natural cycle. This is about engineered solutions and technology that actively remove carbon dioxide from the atmosphere. They capture it and then they store it, supposedly permanently, often in a disused oil and gas well. Now, there's quite a few technologies under here. Usually we split these into two categories. The first one is called direct air capture or direct air carbon capture and storage, which we can refer to as DACS. So this captures the CO2 directly from the atmosphere via an industrial process, a bit like an air conditioning unit, and stores it underground. The second is bioenergy carbon capture and storage. This is using biomass. So you grow a crop or trees, and you then burn that biomass and you generate energy, and you also capture the carbon at the exhaust and you store that carbon underground. Or if you produce something called biochar, you can also store it in the soil. So we're going to talk through these couple of things. Just to give you a bit of a pictorial diagram of this, the problem obviously today is that we're extracting fossil fuels, crude oil from underground. We refine those and make petrol, diesel, and kerosene for burning in an aircraft. And we are adding additional carbon into the atmosphere that wasn't there before in recent history, and that's causing global warming. So this amount of carbon is increasing every year. What we're proposing here is, firstly, direct air capture is basically massive fans that suck air in, they remove carbon and they store that underground. You need to power that with something, ideally renewable electricity. The other option is to have carbon taken from the atmosphere using biomass. So, for example, growing trees, you cut those and you take them to a power plant that produces electricity. It emits CO2, but you can capture some of this CO2, supposedly, and store it underground. The obvious other kind of example here is that there's biomass waste available as well. So we don't necessarily need to deforest areas of the planet. We could also maybe use biomass waste. But obviously, this then competes with another aviation demand, which is for this waste to be used for sustainable aviation fuel, so-called sustainable aviation fuel. So just because negative emissions technology might be a new term for you, you also see carbon capture and storage used. You see carbon dioxide removal, greenhouse gas removal, or engineered removals. These are kind of quite a few different terms that are interchangeable, although carbon capture and storage can mean actually like fossil fuel power station with this attached. Just to kind of cover the industry and the fact that they are talking about this more and more, particularly in the last few years. This is a screenshot I took of British Airways YouTube video on carbon removals. It's showing their emissions growth over the next couple of decades. They've got some aircraft technology that's going to reduce emissions. They've got some sustainable aviation fuel. And the blue section is their carbon reductions and removals, which is a bit vague. They seem to be showing some sort of transition across the 2030s, where they're going to transition from offsets to removals, whatever they mean by that. United Airlines, a few years ago, said that they're going to stop using carbon offsets and they're going to go 100% green by 2050 and remove carbon dioxide from the air using direct air capture. EasyJet have a section on their website talking about technology capturing carbon directly from the atmosphere, securely storing it underground, and they've got a nice diagram showing direct air capture there. And this is one from the Airbus website showing direct air capture as well. So our industry is starting to talk about this and show diagrams about it and kind of take some credit for it. But how much are we actually doing? That's what we're going to explore. And is it even a good idea in the first place? So I'm going to take you through what our positions are. And these are our draft positions at the moment. They're subject to change. Really keen for your input and discussion, and we can always modify these. But let's just kind of present it as it is at the moment. The first thing is we think nets are unreliable. And this is the first one that we put as the highest priority because it sort of cuts through everything else. It says, like really, we cannot rely on them. We need to basically assume that they're not going to work. Why is this? It's because currently they're undeveloped. We've basically got no negative emissions technology facilities at the moment. There's like a couple. They're very tiny. They're very nascent technology. So we will develop them and we will scale them up far too late, even if we go all out right now. So what do we mean by that? So in order to keep global warming below 1.5 degrees and avoid catastrophic runaway global heating, at the current emissions levels we've got today, we're going to exceed that threshold, around 2030. Arguably, we might have already exceeded it today, even if we stop. But we certainly know that we've got less than 10 years to rapidly reduce emissions if we stand any chance of this. Above that temperature, why is that a problem? Well, there's lots of climate feedback loops that we think could lead to permanent and irreversible impacts. The irreversible part is really important. So we develop nets in, 20 years' time, we start to remove carbon. That means, yes, we could remove carbon and maybe reduce the temperature, but we maybe can't recover the Arctic sea ice that's been lost, the glaciers. If rainforest has died, that won't be returned. If species have become extinct, they're not going to magically reappear just because the carbon's been removed later on. So nets won't be scaled up in the next 10 years, and it might be incapable of lowering global temperatures back to safe levels afterwards. Therefore, the potential existence of large-scale negative emissions sometime in the future shouldn't distract us from actions that reduce carbon emissions this decade. I put this as text on the screen because I just think this is a really important thing to work through and understand, is whether you or not you think they should be scaled, how much money you think we should be putting into them right now, it cannot be a distraction from genuine emissions reductions today. Without that, we will fail on climate targets. And I think any discussion of negative emissions should be prefaced with this disclaimer that says it's not a solution and it's not a replacement for reducing aviation emissions. Just a bit of kind of maths on this. If we have 1.5 degrees C, we want a 50-50 chance. We have 7 years, 1.7 degrees, we've got 15 years. 2 degrees, we've got about 25 years. But obviously we're aiming for as close as possible to 1.5 and well below 2 degrees. So we've really not got much time at all. There's quite a nice animation. This is basically, is this going to play? Yeah. So imagine the atmosphere is like a bucket. We're filling it up with CO2. We've been doing this for the past 200 years. The more carbon that is in the atmosphere, the higher the temperature. We are rapidly running out of our carbon budget, and we're getting faster and faster every year, more and more emissions. We've got about 8% of our budget left for 1.5, and that is going to be exceeded in about 7 years. Once we get past that point, we run a risk of all of these. I'm not going to go into detail on them, but lots of tipping points being passed. And those are tipping points that we maybe cannot go back on once the Amazon rainforest has died. Reducing carbon from the atmosphere won't help it recover. So kind of simple, no nets on a dead planet. We can suck the carbon back out afterwards, but if we've already caused these catastrophic impacts, it's not going to be able to repair them. The next thing is that, even if we could kind of magically click our fingers and have widespread negative emissions technology all over the planet at scale today, we don't actually know if it will make the situation better or indeed worse. So let me take you through why that is. We haven't demonstrated these technologies at any significant scale, and it's likely once we get that scale, there's severe risks, technical, some humanitarian, some environmental, that might result from doing this on a large scale. So let's just look at BECCS first. So with bioenergy, it's likely we'd need a massive expansion of industrial agriculture or forestry. This could cause more emissions than it captures because of the land use change, because of deforestation, and it might just keep on making things worse. It requires huge land areas that aren't available, particularly as we're going to have climate impacts impacting our agricultural system, rising sea levels. We're going to be struggling to feed a growing population at the same time as we're massively ramping up our bioenergy. Seems pretty dangerous. We're also going to increase the use of polluting fertilizers and pesticides, and this could also lead to land conflicts and global food insecurity. So humanitarian issues start to come into this as well, which is why we then look at direct air capture, which doesn't use as much land, but it does have a massive energy input. This could divert limited low carbon electricity away from more efficient decarbonisation of other sectors, where we will get much faster rates of reduction in fossil fuel if we use the electricity there instead. It could also prolong our dependence on fossil fuel because it's so energy intensive. We could end up using fossil fuels to power them, and that will just prolong fossil fuel use. And ultimately, it might sort of simply necessitate we build nuclear power to do this. But that is massively expensive, and it will take a long time to do, and we're not even getting started. So that as well. With bioenergy, just to illustrate the size of the challenge, if you look at the IPCC models, they assume a lot of negative emissions, but we typically have to cover 1 to 2 times the area of India in biomass to do this. Now, India is one of the biggest agricultural countries in the world. It's similar size to the US. So this is a massive amount of our land, of our arable land, that we need to put aside for this. Now, if you look at BECCS versus DACS, DACS is a much smaller footprint. So the emissions from aviation is about 1 gigaton, and globally, but it's about 40 gigatons. If you want to do 1 gigaton with BECCS, you'd need to cover the entire state of California in this. For 10 gigatons, which is about a quarter of our current global emissions, you need to cover all of Europe. Now, for DACS, 1 gigaton would be actually the size of London covered in these big air conditioning systems, and for 10 gigatons would be the size of Ireland. So you've got a much smaller land footprint for DACS, and that's what makes it look better. However, DACS has its own risks. So basically, most of these technologies involve sucking a large quantity of air through the system. There is a material that causes carbon to stick to it. You then heat up that material and it releases the CO2 and you capture that. There's a couple of different ways of doing this. Generally, these big fans are powered by renewable electricity. You get a liquid sorbent or a solid sorbent to filter the CO2, but then you end up having to heat that. Solid sorbent uses less heat, but still a decent amount. Liquid sorbent is much easier to scale, but it uses even more heat again. And that heat energy in particular needs to come from somewhere. Carbon Engineering are a major DACS producer. They've built one of the biggest facilities currently in Texas. You can see they've got water, renewable electricity that goes in, but they use natural gas, aka fossil fuel, to heat their the liquid sorbent and release the carbon. Now, I actually saw them at Farnborough the other week. I had a discussion with them. They were claiming that the exhaust of burning that natural gas goes through the same filter and they capture all of it. But even if that is true, there's upstream risks from using more and more natural gas for this, particularly methane leakage during extraction, processing, transport. This is called fugitive emissions, and it can lead to very high levels of global warming. So this is a massive risk from doing this at scale as well. The industry even admits this. They say carbon capture is still a distant and unproven option. So just kind of shows that, we have even said ourselves that this is a long way off and it's unproven. The next problem is the inefficiency, and this is kind of related to what I was just saying. But fundamentally, you start off with a fossil fuel. These are really useful because they are energy dense materials, whether it's coal, oil, or gas. You combust that with oxygen and you get carbon dioxide, water, and useful energy out in terms of heat and light. And you can use that to move a car, to move an aircraft. In an aircraft, obviously, we refine oil to get kerosene. We burn that in a jet engine with oxygen to get thrust to move the aircraft along. And out the back comes carbon dioxide. But that then mixes with the rest of the atmosphere, and there's only 400 parts per million carbon in the atmosphere. You then need to filter that out, and you need to put huge quantities of air through some fans to get in contact with your contactors, and that requires loads of energy as well. So it's just an incredibly energy inefficient thing here. You're essentially trying to reverse the combustion process, and it's massively energy intensive. Just for some numbers, for direct air capture, we need about a third of 2022 renewable electricity supply globally to provide enough DACS for aviation at 2019 levels of air traffic. So this would divert energy away from other areas where it could be put to better use. This is how much energy, how much carbon you save using 1 megawatt hour of electricity to power DACS. Now it's better than producing synthetic e-fuel, but that electricity would be much better spent displacing coal or gas on the grid, powering electric vehicles to displace petrol and diesel on the ground, or powering a heat pump to displace a gas boiler. With BECCS, if we were to use waste biomass, we'd need to cover 80% to 140% of the area of India with enough forest to produce enough residue from that forestry to compensate for aviation at 2019 levels. So it's a huge amount of resource that's required. The next problem is because of that inefficiency, nets are incredibly expensive. To give you an example, for BECS, which we kind of have shown can't really scale, this is the cheaper of the two. It's probably about $50 to $200 per ton of CO2. You've then got DAX, which is $200 to more than $1,000. And at the moment, if you want to do DAX, it costs you more than $1,000 per ton of CO2. Now compare this to the CORSIA scheme, which is the pricing scheme for most international aviation emissions. Currently, it's less than $10 per ton of CO2. So we're way off the real carbon price of how much it's going to cost to actually recapture this carbon once it's in the atmosphere. So this is kind of unfair, and it next produces a bunch of different injustices, which I'll take you through. Now, if you look at what our industry is saying, this is a very dominant narrative. It's the idea that any tax on the aviation industry or the airlines is unfair. This is the chief executive of Jet2 recently saying, rising aviation taxes will lead to increasing number of people being priced out of flying. This would be unfair. It'll become something for the rich and privileged only, and they're lobbying heavily against this. But what this means is, of course, we're not raising revenue to pay for negative emissions. Now, if we look at the profile of people who fly, it's only 1% of the world's population who produce half of aviation emissions. The other half is produced by the next 10 to 20% of people. In a given year, less than 10% of people fly internationally. And in their lifetime, 80% of the world's population have never set foot on an aircraft. So if we were to tax everyone equally to fund negative emissions, you'd get a majority of people who have never flown paying for this. Meanwhile, any tax break really benefits a tiny minority of people. So yeah, 80% of the population have never flown. In the UK, in a given year, it's half of people don't fly, 1% of the population responsible for 50%. So most people don't actually benefit from the price of aviation being kept artificially cheap and by the emissions remaining low or unpriced. Those that do benefit tend to be high income, high emitters. Those most at risk of climate impact tend to be low income, low emitters. This is a large socio-economic injustice. The next problem is intergenerational injustice. So at the moment, we've got relatively wealthy people that are producing most aviation emissions. They can emit for virtually free today. And what we're saying is in 20 years' time, someone else will pay. The next generation will pick up the bill for negative emissions. Yeah, so that, and also those are the people that haven't been responsible, aren't responsible for historic emissions, but will have to be maybe paying a large proportion of their future salary towards negative emissions in a world of climate breakdown, where also we've got spiraling energy costs and climate risks that will be causing massive economic impacts. So who should pay for negative emissions? I think this is a really important part because, even with all of the risks, like we clearly need to develop this and scale it to test whether it works, at least at a small scale, but that's going to be expensive. So who should pay? So they could be paid for in a variety of ways. It could be via government funding, which would need to come from general taxation or from dedicated aviation taxes. So jet fuel tax, emissions pricing, frequent flyer levy are all sort of things our group's in favour of, or voluntary payments from the aviation sector, like is currently happening at the moment, but isn't very reliable. Now, the sector argues that because of the significant cost of negative emissions, governments should provide financial support to scale it up so that aviation growth doesn't get affected. The problem with this is we think that using negative emission, so taxpayer money for negative emissions, is a bit absurd. It kind of shows you that the government has been captured a bit by corporations. We've got governments paying out fossil fuel companies basically to do this work, which is problematic. And I'll take you through why we think that is. So if you think about it, at the moment, there's carbon stored underground. We extract that to get oil. And at the moment, the government provides subsidies to fossil fuel companies to do this. So we pay them to pollute today. Now you refine that into jet fuel, you put it in your aircraft, you generate CO2, and then you power direct air capture to capture it back from the atmosphere, store it back underground. What we're saying is we're also pay the government, pay fossil fuel industry to do this as well. Now, does this kind of make sense? Well, an analogy here is a bit like saying there's a vandal that goes around breaking windows at night. We are going to pay them to repair windows the next day. That's just going to give them an incentive to break as many windows as possible to maximize how many windows they can repair. So we're basically, paying the fossil fuel and we're incentivizing them by saying the more emissions that are in the atmosphere today, the bigger your market for carbon removal tomorrow. So they're just going to want to extract as much carbon as they can from underground to maximize the size of that market tomorrow. It's a bit perverse. If you look at what the fossil fuel industry is saying, they've bought up a lot of these companies. They think that direct air capture technology is going to be the technology that helps to preserve our industry over time. It gives us an industry a license to pollute, continue to operate for the 60, 70, 80 years that I think is going to be very much needed. So this is a strategy to prolong fossil fuel investment and infrastructure. So who should benefit? So if we do raise revenue and we do build negative emissions, who should benefit? So it's worth noting many of these projects are currently located in the global north. They provide economic benefit and jobs to nearby communities there in the US or in Europe. They feature court contracts that are often awarded to major energy companies. There's a big one in Scotland that Shell are doing that are also headquartered in the global north. So the countries and the companies that are most responsible for these emissions and for aviation emissions are the ones who will currently benefit from the cleanup operation. However, countries in the global south are most exposed to climate impacts. Their communities are most in need of economic diversification, away from fossil fuels, also away from tourism. And they tend to be located close to the equator in areas with lots of renewable electricity and with hot and humid climates that make negative emissions more cost and energy efficient. So a question that we've got is, should the people that are least responsible and most impacted by these emissions not be the ones who should benefit from the cleanup operation? Cool. So I'd like to get on to questions. So just to give a quick summary, we think nets are unreliable. They'll be unable to reverse climate change. While we should develop them, we should also plan for a failure and assume that they won't work rather than hoping for the best. They're unproven and risky. They might do more harm than good at large scale. They're inefficient. This is a fundamental issue that isn't going to change, and there are limits to how much we can improve the efficiency. Limited low carbon energy, certainly in the short term, is better used elsewhere. They're also incredibly expensive because of this energy intensity, and they're unfair. So relying on them is a recipe for large socioeconomic injustice and intergenerational injustice. But they will need to be paid for by somebody. So ideally, they'd be paid for by the fossil fuel industry, via a windfall tax. But that cost will be passed on to customers, to aviation companies and airlines, and we should factor those into our business models. We should be getting ready for much higher costs for aviation emissions than we're currently predicting today. Now, we do think there's a positive story from this, just to end on a positive note. So if we focus on policies today that drive down fossil fuels, we can keep our planet habitable. That's pretty good. We can keep tourist destinations visitable. We can ensure that there is an aviation sector in 20 years' time that continues to exist. Also, a high emissions price that will eventually pay for negative emissions will incentivize aviation companies to innovate. It'll drive aircraft technology development and it'll create more aviation jobs. We could use some of that emissions price, the revenue, to pay for loss and damage to the most climate vulnerable countries. We'd be doing a good thing. And by making polluters pay, by directing those funds to those areas, we could address rather than perpetuate climate injustices. So yeah, that's all from me. I've got some more kind of backups, but I'd quite like to hear what everybody thinks. Feel free either to raise your hand and then you can unmute your microphone and ask a question, or yeah, you're welcome to put a question in the chat.
Finn, do you want me to stop recording at this point?
Sure. Yeah, go for it. That one.